Magandang araw! So, today we will discuss about types of functions. So, we will be discussing about polynomial functions, rational functions, modulo, signum, and the greatest integer function. So, a polynomial function is defined by the equation y is equal to a sub 0 plus a sub 1x plus a sub 2x squared plus a sub n x to the n, where n is a non-negative integer and a sub 0, a sub 1, a sub 2 up to n is a real number. When we say n is a non-negative integer, so ibig sabihin pwedeng maging exponent ang 0 because 0 is non-negative. No? So pwede tayong magkaroon ng exponent na 0 pataas. Basta integer. With the highest power in the expression is the degree of the polynomial. So, for example, x squared, so that's a polynomial of the second degree. X to the fourth, that's a polynomial of the fourth degree, and so on. So, a polynomial function can be further classified as a constant function if the degree is 0, a general linear function or a linear function with the degree 1, a quadratic function with degree 2, and cubic function with degree 3. I just limited the discussion to the cubic function, though we know that there are other functions of greater degree like the if a function is the fourth degree, so you have the quartic function, no? If it's fifth degree, quintic function, and so on. But the discussion will just be limited to until the cubic function of degree 3. Okay, so what is a constant function? So if the function is defined as f, so that f is a function which brings r to r and is defined as f of x is equal to y, and that is equal to c, where c is a constant in r, meaning it's any real number, then such function is known as the constant function. Okay, so this is how we plot a constant function. So we have a straight line parallel to the x-axis, and if you look at the graph, the domain of the function is r and the range is the constant c. So whatever the value of x is, so x can go from left to right, so from negative infinity to positive infinity. So whatever the value of x is, the value of f of x is a constant. No, in this example, c is 3 halves, no, 1.5, so 3 halves. So for example, even if x is 4, so x is 4, f of x is 3 halves. If x is negative 1, f of x is still 3 halves. So this is a constant function. Again, the range is r, the domain is r, and the range is the constant number c. So an identity function, so this is a linear function, no? Defined by the equation f of x is equal to y and y is equal to x, no, for any x which is a real number. Now, if we graph the identity function, so we will have a straight line which cuts the first and the third quadrant, and the graph passes through the origin. The domain and the range are both r, no? So you know that you can assign any real number as our x, and you will also notice that f of x will also be any real number. It extends infinitely upward as well as downward. Now, the general linear function f of x is equal to y is equal to mx plus b, where m and b are real number. Now, notice that if m is 1 and b is 0, this is reduced to the identity function. Now, if m is 0, so this expression will be 0. We will be left with b, so we have a constant function. So we know that the identity function now and the constant function are both linear functions. Okay, so this is a graph of f of x is equal to 2x plus 1. So we have a slope of m, which is 2, and y-intercept is 1, meaning the graph touches the y-axis at this point, no? Where y is equal to 1. So we have the ordered pair 0, 1 as the point of intersection. So the domain and the range, no, of this function is R. So we have here a general graph, no, of an increasing function, meaning as the value of x increases, the value of f of x also increases. We have a decreasing function, where as x increases, f of x decreases, and we have this constant function where the value of f of x is constant no matter what the value of x is. So we have a polynomial of the second degree, which we call the quadratic function. Okay, defined by this equation, f of x is equal to ax to the second power plus bx plus c, where it is important that a is not equal to 0. Why? If this becomes 0, this expression becomes 0, we will be reduced to a linear function. And we don't want that to happen because we're discussing quadratic function. So if we sketch the graph of a quadratic function, we will have a parabola. So in this case, we have a parabola which opens upward. In this particular example, the range is close interval -4, no? So the lowest value of the range, no, meaning the lowest value of y is -4, and the value of f of x, no, extends infinitely upward. So -4 to positive infinity. But the value of the domain is any real number, no? It could extend infinitely in both directions, positive and negative. So the domain is R, but the range is -4 to positive infinity only. Okay, so we have here two more graphs, no, of quadratic functions. Okay, so in this particular example, no, so the domain is also R, but the range is 0 to positive infinity. So the lowest value of y is 0, and the graph extends infinitely upward. While this one, the range is -infinity, no? So it extends infinitely downward, and the highest value of y or f of x is 4. So the range is -infinity to 4, no? Where 4 is included. And then we have the cubic function, which is a polynomial of the third degree, denoted by the equation f of x is equal to ax cubed plus bx squared plus cx plus d, no? Where it is important that a, which is the coefficient of x cubed, is not 0. Otherwise, this will be 0 and we will be reduced to the quadratic function. Okay, so the domain and the range of a cubic function are both R. Okay, so here's a graph of the cubic function. Okay, so notice that the graph extends infinitely to the right and to the left, as well as upward and downward, and thus we say that the domain and the range are both R. What about the rational function? Okay, a rational function can be represented by a fraction f of x over g of x, no? Where both f of x and g of x are polynomial functions. And it is important that g of x is not equal to 0. Otherwise, we will have an undefined expression. Okay? The domain and the range are, but the range exclude the singularity, no? We do not want the value of x which will make the denominator 0, and those values are not part of the range.